We're on lesson 5 of chapter 3, which is slope and rates of change. First, we'll identify the slope of a line, then we'll use slope and a point to graph a line, and then we'll do a real-world application. Before we move on, we need to know what slope is, and we're going to use these two bugs to teach this example. These bugs are heading in two different directions. First, they are heading left to right, but they are also going up and down. You'll notice that for both bugs. Slope determines the relationship between the up and down and the left and the right. For example, this bug is having a much more difficult time traveling because the slope is higher than this one. This one's a much flatter surface, which would make it easier to walk on. And that's what slope is. It's the relationship between rise and run. It's actually the rise over run. So let's say from the bottom to the top, it's actually 4 feet tall. And then from left to the right, it's actually only 3 feet long. The slope for this bug would be 4 over 3. So we call it a 4 over 3 slope. Let's say the bottom to the top for this bug would only be 2 feet tall, and then it would be 4 feet long. Your slope would be rise over run, which would be 2 over 4. And then you can simplify that to 1 over 2 if you would like to. So if we're looking at slope then, 4 over 3 is a much bigger number than 1 over 2. And that's what you'll see. The bigger the slope, the more you rise compared to run. On a coordinate plane, you can do this the same way. You can find the change in y, remember y is up and down, over the change in x, which is left and right. And you can use that same formula to solve slope on a coordinate plane. So let's do that. It says tell whether the slope is positive or negative, then find the slope. You'll notice that in these situations, both of these ants were going up a positive slope. They were both going up. Neither of them were going down. And you'll see that if they were going down, it would actually be a negative slope. And that's the easiest way to tell. As you're going from left to right on x, what's happening to the y? As we can see here, the y is going down, down, down as you're going left to right with the x. But mathematically, let's prove this as well. So the formula for slope is change in y over change in x, or rise over run. So for example, we go from 3 down to negative 1. So if you look at the y's here, that's 3 on the y-axis and then negative 1 on the y-axis. We see that it went down 4. When it goes down 4, you go negative 4. And then the run would be from this point to this point on x, which would just be a step of 2. We went from negative 4 to negative 2. So it would be negative 4 over 2. Simplify that. Negative 4 divided by 2 is negative 2. So that would be our slope. And because it's a negative, it is a negative slope. So we're just going to say negative. Let's look at this slope then. Remember, it's rise over run, which is change in y, and then change in x. So let's first look at change in y. Going from left to right, we have negative 3 for y, and then we have negative 1 for y. It looks like we went up 2 on the y-axis. So 2 would be our top number. And then our bottom number would be the change in x. We went from negative 3 to 0. That's a change of 3 for the run. So it looks like our slope would be change in y was 2, change in x was 3, 2/3. And that's a positive number. So this would be a positive slope. And as you can see, this one's going up as you go from left to right, and this one's going down as you go from left to right. So that's the easy way of knowing. It's still good to calculate the slope. So now we actually have to use this idea of slope to graph a line. So it's going to give us a point on the coordinate plane and the slope, and we should be able to graph a line from that. For example, it gives us negative 3, positive 2, negative 3 for x, positive 2 for y, and it gives us a slope of negative 3 over 4. And remember, it's rise over run, or change in y over change in x. So we would see it's negative 3 for y, so falling 3, and then a run of 1, 2, 3, 4. So let's do that. So negative 3 would be 1, 2, 3, it drops, and then a run of 1, 2, 3, 4. Here's another dot. Same thing. Fall of 3, 1, 2, 3, run of 4, 1, 2, 3, 4. And that's probably all I can do. If you're going from right to left, if we went backwards here, we could actually do that as well. Then you just do the opposite of both. So instead of falling 3, we'd go 1, 2, 3 up, and then 4 to the left instead of the right. So 1, 2, 3, 4. Then we could actually draw a line from point to point connecting them all. So there would be our line. Here we have a positive 3 slope. And when it gives you just a regular number, you could just do positive 3 over 1. So the rise would be 3, the run would be 1, the change in y would be 3, the change in x would be 1. It gives us negative 1 and negative 2. So if we're going to plot points for this one, I'll use red this time. It would be rise of 3, 1, 2, 3, a run of 1. Rise of 3 again, run of 1. Rise of 3 again, run of 1. If we go backwards, it'll make both opposites, so it'd be fall of 3, backwards 1, fall of 3, backwards 1, which is a little off. And then if we're going to draw the line, we'll start at this dot and we'll connect them all. And there goes our line. Let's do a real-world application then. It says this graph shows the distance a bicycle travels over time. So here's the distance for the dependent variable. The time is the independent variable. Does the bicyclist travel at a constant speed? And then if so, how fast does the bicyclist travel? We see that this line is very straight, which means the bicyclist, yes, is traveling at a constant speed, so constant. But then we could do rise over run to find out his rate or his slope. I have a couple dots pointed out here, so we could find the y and the x coordinates. So it'd be 1 for x, 15 for y, that'll be the first point, 1 and 15. And then over here we have 2 for x and 30 for y, so 2 and 30. For good measure, we'll do this one, 3 for x and 45 for y, so 3 and 45. Remember, slope is rise over run, or change in y compared to change in x. So y went from 15 to 30, so that would be 15, a change of 15. 30 minus 15 is 15. The change in x was only 1. So rise over run would be 15 over 1. The slope is 15, and we're going to say 15 miles per hour. 15 miles per hour, and that would be your slope. So if it was 3 hours, it would be 3 times 15, which would be 45. So the slope does work in this situation.